all the combination, if it is false, then contradiction. For all the combination, if it is true, then it is called as a tautology. That is tautology and a contradiction. A matrix is said to be normal matrix if pre and post matrix multiplication of the conjugate transpose of A with the matrix A is committed. If f dash x changes sign from positive to negative as x increases to the point C, then C is called the point of local maxima and f of C is called maximum value. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to take the discussion of model question paper. So today in this session, I am going to discuss regarding the model question paper for the point of examination. So the question paper will be in the form of 2 marks, 4 marks, 5 marks, 6 marks and 8 marks. Now in this session, I am going to discuss regarding short answer questions, that is for 2 marks. So here in the question paper they will give 12 questions. In these 12 questions you are going to answer any 10. Each question carries 2 marks. 10 into 2 is 20. So 20 marks from very short answer questions. That is, so 10 questions you are going to answer out of 12 questions. Now let me discuss one by one. So these are answer any 10 questions out of 12 questions, each carries 2 marks. Now the first question, write the truth table for the conditional logic considering 2 inputs. Now just write down the truth table for conditional statement, that's it. So you know conditional, that is P conditional to Q. Write down P, Q and P conditional to Q, right? So here what are the values considering the 2 inputs, that is here T, T, F, F, T, F, T, F, right? So T, 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 F, F, T, F, F. So you know in conditional, if true and false is there means it is false, in other cases it is true. True and true is true, true and false is false, false and true is true, false and false also true. This is the conditional statement. So true and true is true, true and false is false, false and true is true, false and false also true. So if you write this much, you will get 2 marks for this. Now move on to the next question. Write the converse and inverse. So you might have been studied converse, inverse and the contrapositive. So converse and inverse for the given conditional statement. What is given? P conditional to Q. This is given. Now write down first one is converse. Converse is nothing but Q conditional to P. So the converse of P conditional to Q is Q conditional to P is the converse, right? Now what is the inverse? Inverse is negation P conditional to negation Q. This is called the inverse. That's it. What is inverse? So inverse is negation P conditional to negation. So if you write this much, you will get 2 marks. 1 mark for converse. Q conditional to P is the converse and the inverse is negation P conditional to negation Q. Suppose if they ask contrapositive. Contrapositive is nothing but negation Q conditional to negation P is the contrapositive, right? So for any conditional statement, P conditional to Q, the converse is Q conditional to P and the inverse is negation P conditional to negation Q. Suppose if they ask contrapositive, negation of Q conditional to negation Q is the contrapositive, that's it. So if you want, you can also explain with an example. Now the next question is, what is contradiction and tautology? So you might have been studied regarding tautology, contradiction. If all the values in the last column are T, 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 then it is called tautology. If all the values in the last column are F, F and F, that is called as a contradiction for any given compound proposition. So that is, a tautology is a compound proposition that is always true. That is always true for all the truth values of its propositions in it. For all the combination, if the truth values are true, then it is called as a tautology. A contradiction is a statement that is always false for all the truth values of the propositions in it. So, for all the combination, if the truth values are t, 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 then it is called a tautology. If for all the combination, the truth values of the proposition are f, 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 f. So, if you get t, t, t in the last column, then it is called tautology. If you get f, f, f in the last column, it is called as the contradiction. So, how to write? So, a tautology is a compound proposition that is always true for all the truth values of its components or proposition in it is called a tautology. Whereas a contradiction is a statement that is always false for all the truth values of the proposition in it. For all the combination, if it is false, then contradiction. For all the combination, if it is true, then it is called as a tautology. That is tautology and a contradiction. Now, move on to the next question. Fourth question. Define predicate and give an example. So, how to define a predicate? Just define the predicate. What is a predicate? Give an example. Now, a predicate is an expression of one or more variables. It is an expression of one or more variable defined on some specific domain. So, that is a predicate is an expression of one or more variable defined on some specific domain. A predicates with variable can be made a proposition by either assigning a value to the variable or by quantifying the variable. Let us take an example. For example, let e of x comma y denote x is equal to y is an example. Let e of x comma y is equal to implies x is equal to y. Let x of a, b, c denotes a plus b plus c is equal to 0. Let m of x comma y denote x is a married to y, x is married to y. These are some examples for predicates. So, that is a predicate is an expression of one or more variables defined on some specific domain. So, let us consider for example, e of x comma y denote x is equal to y. Let x of a, b, c denotes a plus b plus c is equal to 0. Let m of x comma y denotes x is married to y. These are few examples for a predicate. Now, move on to the next question. So, question number 5, write Venn diagram for a minus b by giving an example. Just write down the Venn diagram for a minus b by giving an example. Now, you know what is a minus b? A minus b is nothing but a such x belongs to a and x does not belongs to b. All the elements which are in a but not in b. Let us take an example. If a is equal to 1, 2, 3, 4 and 5. Let us take another example. B is equal to 4, 5, 6, 7 and 8. Let us consider a set. A is equal to 1, 2, 3, 4, 5. B is equal to 4, 5, 6, 7, 8. According to the definition, what is A minus B? A minus B, the difference between A and B is the elements which are in A but not in B. So, we have 1 that is not in B, 2, then 3, that's it, 1, 2, 3 which are in A minus B, elements which are in A but not in B. How to represent this in Venn diagram? Write down the Venn diagram for this. This is A and B. Now, first write down the common elements. What are the common elements? The intersection 4, 5, 4, 5 is the common elements. Now, so A contains 1, 2, 3, 4, 5. B contains 4, 5, 6, 7 and 8. So, this set is called A minus B. This is A minus B. So, these are called the elements of A minus B. Elements which are in A but not in B. So, what is A minus B? A minus B is equal to 1, 2, 3. See, let us take A is equal to 1, 2, 3, 4, 5, B is equal to 4, 5, 6, 7, 8. And what is the difference between A and B? Is A minus B. Elements which are in A but not in B, that is 1, 2, 3. 4 and 5 are the common element. Just write 4 and 5 and they set A 1, 2, 3, B 4, 5, 6, 7, 8. So, A minus B is nothing but the elements which are in A but not in B is 1, 2 and 3 is the A minus B. That's equal to 1, 2, 3. That's it. Now, this is how we are going to represent in a Venn diagram. Now, move on to the next question. Write the determinant of the matrix A is equal to A, B, C, D. Very simple problem. What is given? Given matrix A is equal to matrix A, B, C, D, A, B and C, D. The determinant of this is determinant A, B, C, D is equal to, just multiply A into D minus C into B. That is nothing but AD minus BC is the determinant of A. So, determinant of A is equal to AD minus BC is the determinant of this matrix. That is it. Okay. So, A, B, C, D is given. Determinant of this is determinant A, B, C, D. Multiply A into D minus B into C. AD minus BC is the determinant of this. Now, move on to the next problem. If A is equal to 1, 2, 3, 4, B is equal to 1, 2, 3, 4, same values, find A into B. So, this is nothing but matrix multiplication. So, just write down A into B. A into B. What is A? A contains 1, 2, 3, 4. 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 1, 2, 3, 4. So, this is 2 rows, 2 column, 2 rows, 2 column. These two elements are same. So, we can multiply and the matrix we are going to get is of order 2 rows, 2 column. So, you know matrix multiplication, first row, first column, second column. 1 into 1 is 1 plus 2 into 3 is 6. Again same row, second column, 1 into 2 is 2 plus 2 into 4 is 8. First row, first column, second column. Similarly, second row, first column, second column. Second row, first column, 3 ones are 3 plus 4 threes are 12. Again, second row, last column, 3 twos are 6 plus 4 fours are 16. So, this is equal to 6 plus 1 is 7, 8 plus 2 is 10, 12 plus 3 is 15, 6 plus 16 is equal to 22. So, therefore, the matrix A into B, AB is equal to 7, 10, 15 and 22. This is of order 2 rows, 2 columns. That is it. This is how we are going to multiply the matrix AB, matrix multiplication. Move on to the next problem. So, question number 8, prove that A dash whole dash is equal to A. Now, transpose of a transpose is equal to the same matrix. Now, let us consider, let A is equal to A, B, C, D. Transpose this. A dash is equal to, the transpose of this is A, B, C, D. Transpose. Just first row becomes first column and second row becomes second column. So, A, B, C, D. Again transpose this. Transpose of this. A dash whole dash is equal to transpose this. So, A, C and B, D. What is this equal to? So, A, B, C, D, this is nothing but same. So, therefore, you can write A dash whole dash is equal to A. Transpose of a transpose in matrix is equal to the same matrix. Or you can also solve by taking an example like this. Let us take an example. Or you can also write like this. Let A is equal to 1, 2, 3, 4. Transpose this. A dash is equal to, transpose of this is 1, 2, 3, 4. So, first row becomes first column, second row becomes second column. Transpose this. Again, A dash whole dash is equal to 1, 3, 2, 4. What is this equal to? 1, 2, 3, 4 is nothing but A. So, you can write A dash whole dash is equal to A. The transpose of a transpose in matrix is equal to the same matrix you are going to get. A dash whole dash is equal to A. Now, move on to the next problem. What is the normal form of a matrix? Give an example. Normal form of a matrix with an example. Now, a matrix is said to be normal matrix if pre and post matrix multiplication of the conjugate transpose of A with the matrix A is commutative. If A is said to be, the matrix A is said to be normal matrix if pre and post matrix multiplication with the conjugate, pre and post multiplication of the conjugate transpose of A with its matrix A is commutative. That is, in other words, normal matrices are those matrices whose matrix multiplication with its own conjugate transpose is commutative. if matrix multiplication with its conjugate, own conjugate transpose is commutative. Let us take an example. For example, if A is equal to 1 minus 1 and 1. So, let us take the transpose of this. A dash is equal to, the transpose of this is 1 minus 1, 1 and 1. Now, for a normal matrix, A into A dash is equal to A dash into A, that is commutative. Verify this. Now, just find out A into A dash. What is A into A dash? A is 1 minus 1, 1, 1 and A dash is equal to 1, 1 minus 1 and 1. Multiply this. First row, first column, second column. So, 1 into 1 is 1, minus into minus plus, 1 ones are 1. 1 into 1 is 1, minus into plus it is minus 1. Again 1 into 1 is 1, minus into plus it is minus 1. 1 into 1 is 1 plus 1. That is equal to 2, 0, 0, 2. This is A dash into A. Now, find out A dash into A. What is A dash? A dash is 1, 1 minus 1, 1. This is transpose and A is equal to 1 minus 1, 1, 1. Check whether you will get the same answer or not. First row, first column, second column. 1 into 1 is 1 plus 1 into 1 is 1. Again 1 into minus 1 is minus 1 plus 1. Again minus 1 into 1 is minus 1 plus 1. Minus into minus plus 1 plus 1. So, this is equal to 2, 0, 0, 2. What you will get? So, what do you say from these two? A dash is equal to A dash into A is equal to A into A dash. So, therefore, this is an example for a normal matrix. That is it. Hope you followed. Now, move on to the next problem. Define the points of local maxima and local minima. So, this is one of the application of derivatives. Define local maxima and local minima. Now, if f of x is a function, suppose if y is equal to f of x is a function, differentiate this. If you differentiate with respect to x, what you will get? Dy by dx is nothing but f dash of x. So, for the function to be maxima or minima, f dash of x is equal to 0. If f dash of x is equal to 0, the function is said to be maxima or minima. Now, the condition number 1. Suppose if f dash x changes sign from positive to negative as x increases to the point C, then C is called the point of local maxima and f of C is called maximum value. So, if f dash of x changes from positive to negative, f dash x changes from positive to negative as x increases to the point C, then the point C is the point of local maxima and f of C is called as maximum value. Similarly, if f dash of C changes sign from negative to positive as x increases through the point C, then C is called the point of local minima and f dash of C is called as the minimum value of the function. So, if f dash is called the maximum value of the function, that means the point C is called as the maximum. That means if f dash x changes from positive to negative as x increases, and suppose if f dash x changes from negative to positive as x increases, then C is called as the point of local maxima and local minima. That is it. Okay, very important definition. Now, move on to the next problem. Write the power rule of differentiation. Now, power rule of differentiation. Power rule of differentiations. Power rule of differentiation is nothing but d by dx of x to the power of n is nx to the power of n minus 1, where n is any rational number, positive integer, negative integer or a fraction, positive or negative fraction. Take an example. For example, d by dx of x to the power of 4 is equal to 4x to the power of 4 minus 1, that is equal to 4x cube. This is called the power rule of differentiation. So, d by dx of x to the power of n is nx to the power of n minus 1, where n is a rational number, positive or a negative fraction. For example, d by dx of x raised to n is nx to the power of n minus 1, 4x to the power of 4 minus 1 is 4x cube. So, if you write this much, you will get 2 marks. Now, move on to the next, last in this 2 marker question. Find the first order derivative of the function f of x is equal to x to the power of 4 plus x square plus x. So, what is required to find is the first order derivative. First order derivative is nothing but f dash x. Second order derivative means f double dash x. Now, what is given? F of x is equal to x to the power of 4 plus x square plus x. Now, differentiate this. Differentiating with respect to x. Differentiating with respect to x. So, we will get f dash of x is equal to d by dx of x to the power of 4 plus x square plus x. So, term by term differentiation, d by dx of x to the power of 4 plus d by dx of x square plus d by dx of x. Now, using power rule, differentiation of x raised to 4 is 4x to the power of 4 minus 1 is 3 plus differentiation of x square is 2x plus differentiation of x is 1. So, therefore, f dash of x is equal to first derivative is 4x cube plus 2x plus 1 is the first derivative. Suppose if you differentiate this one more time, you will get the second derivative, but that is not required. So, what is required to find is the first derivative. First derivative is nothing but dy by dx, or it is also equal to f dash of x is the first order derivative. So, differentiation of x raised to 4 is 4x cube, x square is 2x plus x is equal to 1 is the answer. That is it. So, these are few problems for 2 markers. These questions are from previous year examination, that is last year examination question paper. So, hope you follow. That is all regarding today's session, and let us discuss the remaining part in the next session. Thank you very much.